Every night when you look up at the sky, you're seeing the light of 400 billion stars. Statistically, there should be millions of intelligent species. But SETI has been listening for 70 years. Complete silence. This is one of the universe's greatest mysteries. Carl Sagan dedicated his life to this question. Where is everybody? This question emerged from a simple inquiry physicist Enrico Fermi posed during lunch at Los Alamos in 1950. But this simple question became the foundation of modern astrobiology. Fermi that day was discussing UFO sightings and alien visitation claims with colleagues Emil Konopinski, Edward Teller, and Herbert York, the brilliant minds of the Manhattan Project. The conversation started jovially, but Fermi made a serious point. "You know," Fermi said, "it's an interesting question." Then came the famous words, "Where is everybody?" Fermi's logic was simple. Our galaxy is 13.6 billion years old. Our solar system is only 4.6 billion years old. This means civilizations could have evolved billions of years before us. If even one achieved interstellar travel, they should have colonized the entire galaxy by now. Simple mathematics. Even at modest speeds, say 1% light speed, traversing the galaxy would take 10 million years. That's nothing compared to galactic timescales, as Fermi put it. They should be here by now. Carl Sagan encountered this paradox in the 1960s, and it became his life's passion. There are two possibilities in the cosmos. Either the universe is full of intelligent life, or we are alone. Both are equally terrifying. So how likely is alien life really? Let's turn to mathematics. Begin with the Drake equation. In 1961, astronomer Frank Drake, with Carl Sagan's contributions, developed a formula to estimate how many communicating civilizations might exist in our galaxy. At the Green Bank Conference, SETI's founding moment. NR tree trake FP treat. Now coffee robert. One will be found out cover, but the Green Bank can you modern, the vol about Eddie Moshtuli, Molgever Frinchidai. In the past it was much higher. Peak star formation occurred 10 billion years ago. FP, what fraction of stars have planetary systems? Since the first exoplanet discovery in 1995, 51 Pegasi b, we've confirmed over 5,000 exoplanets. The Kepler mission showed nearly every star has planets. This value ranges from T5 to 1.0. Nay, how many planets per system are in the habitable zone? The Goldilocks zone, not too hot, not too cold, just right for liquid water. For main sequence stars, typically 0.1 to 2 planets per system lie in the habitable zone. Flel, on habitable planets does life actually emerge? This represents enormous uncertainty. On Earth, life emerged very early, possibly 4.1 billion years ago, but our sample size is N1. Maybe life is inevitable given the right conditions. Maybe it's incredibly rare. Abiogenesis, life from non-life remains mysterious. Miller-Urey experiments in the 1950s produced amino acids. The RNA world hypothesis suggests self-replicating molecules. Hydrothermal vents provide energy gradients. Clay minerals catalyze reactions. Recent discoveries are encouraging. Complex organic molecules in space. Amino acids in meteorites. Subsurface oceans on Europa and Enceladus. Methane on Mars. But none of this constitutes proof of life. Phi, does life evolve into intelligence? Evolution on Earth took 3.8 billion years to progress from single cells to complex multicellular organisms. The Cambrian explosion occurred 540 million years ago. Consciousness is very recent. Homo sapiens emerged 300,000 years ago. Intelligence might represent convergent evolution. Eyes evolved independently over 40 times. Maybe intelligence is inevitable given enough time. Or maybe it's extremely rare. We don't know. FC, do intelligent species develop communication technology? Homo sapiens did. Radio waves were discovered by Hertz in 1886. Television in the 1920s. Radar in the 1930s. Satellite communication in the 1960s. Internet in the 1990s. But technology development isn't inevitable. The Mayans and Incas developed complex astronomy but not radio. Intelligence doesn't guarantee technology. L. How long do communicating civilizations survive? This is the critical variable. Nuclear weapons have existed since 1945. Climate change is accelerating. AI development is rapid. Biotechnology is advancing. Carl Sagan worried about technological adolescence, the period when civilizations have the power to destroy themselves but not the wisdom to avoid it. Maybe most species fail to pass through this phase. Conservative estimates put L at 5,200 years. Optimistic estimates suggest millions of years. This variable dominates the equation. Using optimistic calculations, Carl Sagan estimated 1 million civilizations in our galaxy. Conservative estimates suggest 10,000. Pessimistic estimates, just 1 minus, only us. Frank Drake's original calculation estimated 1,000 to 100,000 civilizations, a wide range reflecting enormous uncertainties. But mathematical probabilities aside, what does observational evidence tell us? SETI, Search for Extraterrestrial Intelligence, began in 1960 with Frank Drake's Project Ozma. Using the 85-foot radio telescope at Green Bank Observatory, he listened to 2 nearby star systems, Epsilon Eridani and Tau Ceti. After 150 hours of observation, he detected no artificial signals. Carl Sagan became SETI's champion from the 1960s onward. He secured NASA funding. He used the Arecibo Observatory. He organized international cooperation. In the 1970s, joint SETI efforts with the Soviet Union occurred. SETI, Communication with Extraterrestrial Intelligence. Both sides cooperated despite political tensions. Science transcending politics. 1977 brought a breakthrough moment or mirage. The Big Ear radio telescope at Ohio State University detected a 72-second signal. Jerry Amon was working the night shift. He saw the narrowband signal on the computer printout and wrote "wow" in the margin.
The signal characteristics were impressive. Frequency 142456 MHz. Hydrogen's characteristic emission line. A universal constant any technical civilization would know. It was 30 times stronger than background noise. Perfect narrow bandwidth. Non-repeating. But the signal never returned. Follow-up observations found nothing. Natural phenomenon? Equipment malfunction? Genuine alien transmission that stopped. Carl Sagan was excited but cautious. Extraordinary claims require extraordinary evidence. A single detection was insufficient. Repeatability, verification, and content analysis were needed. The 1980s saw the founding of the SETI Institute. Carl Sagan, Frank Drake, and Jill Tarter led the effort. Private funding became necessary when government support disappeared. The Contact novel and movie helped provide funding. The 1990s brought comprehensive sky surveys. Projects Phoenix, Serendip, and Beta observed millions of stars. Sensitivity improved by orders of magnitude. Still no confirmed signals. In 2015, Breakthrough Listen was announced. Yuri Milner committed $100 million to the most comprehensive SETI search ever undertaken. 1 million nearest stars, 100 nearest galaxies, all sky surveys, advanced algorithms, machine learning, AI pattern recognition, real-time processing, citizen science involvement. Current results after 8 years, 0 confirmed artificial signals, thousands of candidates investigated, all explained by terrestrial interference, natural phenomena, or instrument artifacts. How can this cosmic silence be explained? The Great Filter Theory offers the most compelling explanation. Robin Hansen proposed it in 1996. There's a bottleneck in evolution, an extraordinary difficulty. Very few species pass through. Where is the filter? This question is critical for humanity's future. Possible early filters, abiogenesis. Life from chemistry is extremely rare. Prokaryotic to eukaryotic transition. Complex cells are rare. Multicellularity. The cooperation versus competition balance is difficult. Sexual reproduction. Balancing genetic mixing with individual survival. Complex nervous systems. Intelligence emergence is rare. If the filter is behind us, we are lucky survivors. Intelligent life is very rare in the galaxy. This would explain the silence. Possible late filters. Resource depletion. Sustainability is impossible. Climate change. Planetary regulation fails. Nuclear war. Mutually assured destruction. AI alignment problem. Uncontrolled artificial superintelligence. Biotechnology risks. Engineered pandemic. Nanotechnology risks. Grey goo scenarios. If the filter is ahead of us, our future is very dark. Advanced civilizations inevitably self-destruct. Carl Sagan was deeply worried about nuclear winter. A nuclear war can be won by nobody. The nuclear arms race is like 2 sworn enemies, standing waist-deep in gasoline, one with 3 matches, the other with 5. Climate change represents another civilizational threat. We have reached the point where our impact on the climate is comparable to the natural forces that have shaped it over geological time. Maybe every intelligent species reaches technological power before ecological wisdom. The Fermi Paradox becomes a great filter warning. Alternative explanations exist. Zoo hypothesis. Aliens know about us but avoid interference, like a wildlife preserve. Star Trek's Prime Directive. A non-interference protocol with primitive civilizations. This requires galactic coordination, all species agreeing to preserve Earth. Possible but requiring extraordinary cooperation across vast distances and timescales. Dark Forest Theory. From Liu Cixin's 3-body problem trilogy. The universe is a dark forest. Every civilization is a hunter. Revealing location means death.
Everyone stays quiet for survival. Logical but depressing. It suggests a universe filled with paranoid civilizations afraid of each other. Mutual fear preventing contact. Transcension hypothesis. John Smart's proposal. Advanced civilizations turn inward instead of outward. Physical space exploration becomes inefficient. Virtual worlds are more attractive. Following miniaturization trends. Computing power increases while size decreases. Maybe advanced civilizations exist in quantum computing substrates. The physical universe becomes irrelevant. Rare Earth hypothesis. Ward and Brownlee's argument. Simple life may be common, but complex multicellular life is extraordinarily rare. Earth's special conditions. Large moon for tidal effects and axial stability. Jupiter as comet deflector. Roundrow magnetic field for radiation protection. Roundrow right distance from galactic center. Stable circular orbit. Right stellar type and age. All these conditions together might be incredibly rare. Maybe complex life exists on very few planets. Communication problems also exist. Technology mismatch. We use radio waves. They might use quantum entanglement, gravitational waves, neutrino beams, or physics we don't understand.
Distance problems. The galaxy is enormous, 100,000 light years in diameter. Even light-speed communication requires millennia for round trips. Lifespan mismatch. Civilizations might be short-lived. The technological phase lasting only centuries or millennia. In galactic timescales, civilizations rise and fall like flickering candles. Recent developments offer hope. Exoplanet science has been revolutionized. Kepler discovered thousands of planets. TESS continues the survey. James Webb analyzes atmospheres. Proxima Centauri b, the closest exoplanet, 4.2 light-years away, in the habitable zone. But red dwarf flares are problematic for life. TRAPPIST-1 system, 7 Earth-sized planets, 3 in the habitable zone, 39 light-years distant. Atmospheric analysis is ongoing. K2-18b, water vapor detected in the atmosphere, 124 light-years away, sub-Neptune size, potentially habitable. Biosignature detection is advancing. Oxygen plus water vapor, potential photosynthesis. Methane plus oxygen, potential biological process. Industrial pollutants, technosignatures. The James Webb Space Telescope analyzes exoplanet atmospheres with unprecedented precision. Technosignature searches are expanding. Artificial illumination on planet nightsides. Wandustrial atmospheric pollution. Megastructure construction around stars. Wandustrial. Laser communication intercepts. China's FAST telescope is operational. 500-meter aperture. The world's most sensitive single-dish radio telescope with dedicated SETI time. AI and machine learning are revolutionizing SETI. Pattern recognition algorithms. Wandustrial. Deep learning classification. Real-time signal processing. Wandustrial. Anomaly detection. Carl Sagan's legacy continues. The Contact novel 1985 and movie 1997 inspired a generation of scientists. Realistic portrayal of the SETI discovery process. Extraordinary claims require extraordinary evidence. Still the guiding principle for SETI research. Cosmic perspective philosophy. Understanding our place in the universe through the search for others. The SETI Institute continues his work. Jill Tarter, former director, was inspired by his vision. Personal implications. Looking at the night sky differently. Every star is a potential home to intelligence. Someone might be looking back. Existential questions. Are we alone? Are we first? Are we special? Are we in danger? Cosmic loneliness versus cosmic community. Both prospects are profound for human meaning and purpose. Carl Sagan remained optimistic. I think it would be a positive development for humanity. Any civilization capable of interstellar communication would have solved many of the problems we face. But he cautioned, we should be careful about advertising our presence until we know more about the neighborhood. The next decade is crucial for biosignature detection. James Webb might find definitive signs of life. Radio SETI sensitivity is improving exponentially. AI advancement might reveal signals hidden in existing data. Where is everybody? Maybe the answer is right here, searching for each other across the cosmic dark. Maybe, hiding in fear of the unknown. Maybe, we are the first to ask. Each possibility changes everything about human meaning and cosmic destiny. 70+ years of systematic search. Cosmic silence so far. But the universe is patient. The search continues. Carl Sagan would be proud. The vision he helped create is growing stronger. Technology is advancing. International cooperation is deepening. The SETI search defines us as a species. It demonstrates hope, curiosity, and cosmic perspective. Looking up at 400 billion stars, wondering, hoping, listening. And maybe somewhere among those distant suns, someone is looking back, asking the same question. Where is everybody? We are here. Are you?